So this is the last part of 8.2. I'm calling it 8.2b. This is the part that covers arithmetic series. Remember, this series is just an arithmetic sequence that's being added together. We have a formula for finding that arithmetic series, derived by a mathematician called Gauss. He was also responsible for the fundamental theorem of algebra. Remember, that says you have as many roots to an equation as your highest degree. He identified the bell-shaped curve of a normal distribution in statistics. And when he was a youngster, he annoyed his tutor so badly that the tutor wanted him to shut up and be quiet, and so he said, add the numbers from 1 to 100 and give me a few minutes. Well, Gauss did it in about 2 seconds. The way that he did it led to this formula. So he took the numbers 1 to 100, and he noticed that if he added 1 and 100, it was 101. And if he added the next pair, 2 and 99, that was 101. And 3 plus 98, that was 101. And that left him 50 times with 101 for 5,050. Yes, the tutor was astonished, but it led to this equation. So I have the sum, we write it with not the sigma notation, well, for the formula, we write S for sum. N stands for the number of terms in that sum. There's the number of terms. I'm taking the first term and the last term in the series and dividing that by 2. So I'm averaging those terms and dividing by the number of terms in the sequence. You can see when Gauss did it 50 times, 101, 100, that's, if I'm looking at this formula, I have 100 terms. Its first term was 1, the last one was 100, dividing by 2. That's equivalent to moving that 2 to the outside, and so it's 100 divided by 2. 50 times 101 is that same 5,050 that Gauss came up with. If I'm looking in your book at, I think it's example 5, it is, as I already wrote it on the board, example number 5, where you were asked to find the sum of this sequence starting from 1 and going to 20. So if I'm using this formula, that means first I have to figure out what the first term is. So a sub 1, I'm letting I be 1, and that's 3 times 1. So a sub 1 is 3 plus 7 or 10. And I need to know what the 20th term is, because that's the last term. So a sub 20, the last term in our sequence is going to be 3 times 20 is 60, plus 7 is 67. And then we're just going to apply the formula. So the sum for those 20 terms is 20 times 10 plus 67 divided by 2. I could do it in that order. I could move that 2 out and make that 10 times 77, or 770. And if I'm doing mental math, that's a whole lot easier than 77 divided by 2 times 20, or just think of it as canceling, multiplying by 10. However you want to think about it, 770 was the way to get there. If we're looking at example number 6, this should be a very short lesson. So relief to us all, I know. Leaving that formula up there. Example number 6. Look in your book at this is on page 421. There's a picture of a deck of cards. And then they're asking you to write a rule for the number of cards in each row. And they're calling that top row. So when I'm looking at my terms, a sub 1 is going to be the number of cards in that top row. So in that top row, there were 3 cards. And then it's asking you to, so basically what we have is an arithmetic sequence where the first term is 3, and the difference is also 3, because each row goes up by 3 cards. So if I'm writing my rule for that, a sub n is the first term, so 3 plus n minus 1 times that common difference is 3, and we distribute so we can find out what we're going to be putting in our summation. So that equals 3 plus 3n minus 3, or a sub n just equals 3 times n. That means that what we're actually summing is going to look like n is going to go from 1 to, how many rows? 12. And we're looking at 3 times n And that's how we can get there. I think I need the first term, which we've already found. So I need, in order to use this formula, we need an a sub, we know that n is going to be 12. We know that our a sub 1 is going to be 3. And now we need to find, now we're going to be dividing by 2. And I need to find that last term. So if n is 12, 3 times 12 is 36. And so I have 3 plus 36, first term to last term. The number of terms, and I'm dividing by 2. So that's 6 times 39, whatever I get when I do that, looks like 234. So 234 cards in that 12th row. So far, so good. And then the last thing to look at is monitoring progress. It's down at the bottom of page 421. This formula will also be something to remember and that means memorize. So if I'm looking at number 7, this is monitoring progress, you can either pause and come back and see how you did or just bear with me. So in the first one, they told you a sub 1 was, they didn't. In the first one, they gave you a summation, but from that summation, a sub 1 was 9. They were asking you to go through 10, so you need to know the 10th term, and I'm using that summation symbol, so it's 9 times I is 10, so the 10th term is 90. And when we plug in, the sum for those 10 terms is the number of terms, so 10, times the first term, plus the last term, divided by 2. And when I do that, you should have ended up with 495. 5 times 99. If I'm looking at number 8, from that summation that they gave you, 7k plus 2, I know the first term is going to be 9. We know that the 12th term, you're plugging back into that formula, so 7 times 12 plus 2 is going to be 86. At that point, we're ready to use the formula. So that sum for 12 terms is 12, because that's the number of terms. The first term plus the last term in the series divided by 2, and that equals 570. So far, so good, I hope. And then if we look at number 9, they gave you a sum that ranges from n to 20. And so that first term, applying that formula, is 2. And the 20th term, I'm plugging back in and finding that's negative 74. So the sum for those 20 terms is going to be 20, because they're 20 terms. The first term is 2. The last term is 74. You're dividing by 2. And when you do that, you should end up with negative 720. For number 10, I'm back to that deck of cards, and there were, how many cards do you need to make a house of cards with 8 rows? So 8 rows, remember the first row had 3 cards, and the common difference was 3. And so if I'm looking for 8 rows, I'm thinking a sub 8 is going to be the first term, so 3. 8 minus 1 is going to be 7 times 3, or 3 plus 21. So I would have 24 cards in that final row. So a sub 1 is 3, a sub 8 is 24, 8 rows. So our sum for those 8 rows is going to be 8, because that's the number, that's our n. My first one is 3, my last one is 24. I'm dividing by 2. And when I finish that, I should end up with 108 cards in that last row. That finishes this lesson. You have 2 worksheets. They're not as many problems. So 2 worksheets. They're under the Topics tab in the answers for your homework assignments. Look at worksheet 1 and worksheet 2 for section 8.2b. And I'll see you the next time.